how to hook a local base station up to our computer. So all new computers these days, they all you've got two options for connection to a rover head or a base head for GPS connection, and that's typically going to be either 2.4.4. I didn't know this. I was waiting on Sensefly to come out with this. What's been sent with this newest release of 2.4 software is this will also record the raw files in the receiver. So if you will have your base station set up over an unknown point, you can log corrections on the base, and the plane will also record that GPS data. You can download it all and do an OPUS position on the base station, and it will automatically correct all the vectors to the plane. So this happens a lot because, you know, if you're hardwired to the base station, you may not be able to walk over the side of the hill to plug your unit up. This doesn't look very big, and we'll take but a second. So in this option, you may just want to set the base right behind your truck, wherever it may be, and process the coordinates of that base station later. And we haven't been able to do that up to now. And I'm seeing here that it's here now. So I'm gonna install it here real quick while this is going through. So other things that I've noticed using a local base station with the EV RTK unit is the second option for connection is going to be through a Bluetooth connection. And anything with Bluetooth in a desktop PC, I've noticed, at least with my limited expertise on Bluetooth connections, is we have to have a PIN number in that receiver. If we don't have some sort of PIN number to establish a serial port, or I guess a virtual serial port to that rover or base head, then it's not going to connect and stay reliably connected. So for in the instance of Popcorn, I have to establish a PIN number in that base station and make sure that my computer has a solid pairing to that base head. So then it'll create like a COM8 or a COM9, and it's fairly easy to get this thing there. So once the connection is rock solid, then it's pretty easy to work with. You can put that, I know, like a Topcon Hyper SR, you can put it a couple hundred feet away from the truck with Bluetooth. But in our last exercise that we did Friday last week, we had a serial cable hooked up to it, and that worked really well till the client went and stepped on the cable. So that's the only thing you got to worry about, cables. Then you got cables to trip over. I'll show how we do that. But then you've got USB serial port replicators that you have to pick up and use. So any software updates that are coming available for Sensefly, it's all available if you go to my.sensefly.com. There is a new revision of Post-Flight Terra 3D. Oops. I don't recommend it. Not yet. It automatically classifies the point cloud during the processing run, which is really cool in one regard. But it makes it take way longer, and the software's got some bugs and causes it to crash. So I still recommend that you So there should be a products icon here somewhere. My products. Is my computer screen, is it choppy on because the internet seems to be stalling a little bit. Yeah, right here's the two versions of Post-Flight. This is the brand new version, and if there's anybody who looks at this and decides they want to download it, I'm going to ask you to go ahead and hold off on that until we just had too many bug reports, ran into it myself. I had issues with the software crash in between step 1 and step 2. But this is where you can download additional copies of the software and give you the warranty information for your plane. Currently, I don't know if mine's expired or what it's done, but nonetheless, this should give you all your software downloads if you ever need them. The manuals are on there as well, and there's also the knowledge base that's available on the Sensefly website. So I'm going to open up eMotion 2 again now that we have a new version. Here we are. So we have our simulator, which we're going to have to use today. There's the RTK simulator. There's the standard EV simulator. We're going to do the RTK today. And the plane goes through its pre-flight checks and does what it needs to do to make sure that it's safe to fly, like the runs the IMU or the magnetometer through a couple tests. It checks the servos, checks the wind speed and the GPS position. And now then we can either start piping flight plans into it, or we can update firmware or whatever we need to do. Out by Cave Run Lake. It's a quarry site that a buddy of mine did. I'll go ahead and simulate the position of my plane right here. And it generates a 1,650-foot working area radius. And this can be found right here in this last tab. It says 1,640 feet. We can change that to 2,500 feet. We can change it to more. Typically, I like it to make it just a hair bigger than my flight area. The maximum working area ceiling is 984 feet. I don't change that very often because in where I live, there's a lot of changing terrain, and the plane with the Google Earth surface modeling will keep itself below 400 feet above the terrain. So there was even an instance that the plane on its flight was 20 feet lower than where we put it in the air. During its flight, there was that much terrain change. So we launched from the top of the mountain, and the plane actually was below us, below our feet at that point when it was getting the bottom of the hill. So pretty neat circumstances. So here we can also, inside of eMotion 2, just to start describing some of the menus, we can connect a second plane and actually fly 2 units at one time. We can import a digital surface map from eMotion 2. We can buffer, from eMotion 2, from Post-Flight Terra 3D. So if we'd actually done a flight already, we could import that mapping and use it instead of Google Earth for our terrain, plane to follow the terrain. So we can download and buffer the background image. So if we're going to the field, we're not going to have cell phone coverage. This will download it and buffer it. However, you have to use a Microsoft satellite. You can't use anything from Google because it's a license. So any users that need to remember that, you want to write that down because it won't download. It will just sit there with the next button. But also inside of eMotion 2 now, I figured out that you could actually update the firmware inside of here. And if you're working in meters and you want to work in feet, you got to go to preferences and switch it from metric to imperial. So that's where that stuff is stored. So real quick, how to work a local base station, whether it be Trimble or Topcom, is you're going to use a serial to USB converter. Then there's some things to pay attention to. Number one, the serial to USB converter will switch COM port numbers on you from flight to flight, or every time that you reboot it and plug it in. So I'll go ahead and hook mine up here real quick and give you an idea of what it does. If we go to my device manager, you got to pay attention to this. Just because you create the settings for it, I guess what I'm saying is doesn't necessarily mean that they'll always stay those settings. So this is a USB to serial COM port replicator, and it's COM10 is what it made itself this time. It was COM4 earlier today. So you have to add a base. There's the option for Trimble or TopCon. If you own Leica, you have to set your Leica up to export data out COM whatever, port whatever, RTCM3 message type. So say this is a GR5, and it's a TopCon. We're going to talk over a serial connection. That's going to be COM port 10. It's going to change every time that I take the thing out of there. And you check the box for hardware flow control. And that's pretty easy. But now you have to go to an external program that TopCon has to plug in the base coordinates for that point. And basically that's the same thing for the R8. You can even see where I called it R8, COM7. My replicator had it as COM7 that time. So you can click the gears off to the right if you don't feel like creating a new configuration and just change it to COM port 10. Right there. So there's just some of the little things that you got to remember. And Trimble has a little toolbox called GPS Configurator. You got to hook up to your base station through this before you start eMotion 2 to give it coordinates, and that you want it to send RTCM3, what the base coordinates are, all the above. And it's a touch painful at first till you have that workflow down. Did I kill? I killed eMotion. Yeah. No? All right, we'll connect back up to the EVR. Okay, so now it says RTK source not defined. Of course, there is the option right here to connect up to Ntrip. I think I'll use TopNet Live today. TopNet Live. So now the computer will start talking to the network. It sends the Ntrip credentials to the server. It says my GPS is okay, my GLONASS is okay, and I'm RTK fixed right here on the screen. So what I have noticed using a local base station compared to a network base station is the unit stays fixed a lot better off of a local base station than it does off of the network. Either breaks in cell data or whatever it is, I'm not sure. It just does much better off of a local base station. So here on the site, this area that's shown in trees and whatever has now been disrupted. It's the quarry operation has moved into that area, so that's the area that we wanted to fly. And a couple things to consider during our setup is first we want to set up our flight area, and I don't want to use a rectangle. I want to use polygon because this is not rectangular shape. So I'll move it to there. Move this here. Stretch that to there. And move this here. So this ground slopes from the quarry almost parallel right down to the lake. So what I'll do to adjust for terrain is grab the flight lines and rotate them to where they're running. Well, I'll try anyway. Rotate them to where they're running parallel with the gradient of the hill. There we go. So that being said, it's got a 75 by 75% overlap. It's going to fly at 379 feet. We have the ELF camera selected. That's what I have in my plane, but there is a new version of camera coming out, the WX, which is going to be an 18 megapixel instead of the 16 megapixel that we're using now, and it'll run off the plane's battery instead of its own battery. I know there's a high wall here that the customer was concerned about, we can generate perpendicular flight lines here to get a second perspective on that high wall, because the high wall was parallel to the lake. So it says this total flight is going to take 24 minutes and 22 seconds, flying 37.4 acres. So if I'm happy with that flight plan, I can just upload it, and it's going to use this blue area that you see as a surface terrain model. All right, so our flight plan's been uploaded to the plane now. And if I pan to the right here a little bit, everything looks pretty good. But what I want to double check, which is pretty important, is to pull this up in Google Earth and verify that it's not going to crash into a hill. So that blue area that we saw overlay was our surface terrain. And what that surface terrain keeps us from doing, number one, it keeps our pixel resolution, so if we launch from the top of the hill, we don't lose anything over the valley. But it also keeps us from crashing into things. It's not foolproof, but it is a nice feature, and it's designed to protect the plane and to aid in intelligent flying. Is my screen real? Is everything moving along pretty good on your all's end? Because I'm under the impression the internet's stalling out.
It's moving pretty good for me.
So zooming into Cave Run Lake here. So if I rotate this guy, we can see the changes in elevation that this plane's making through its whole flight here. You can see that this perpendicular line is lower than this line above it. So it's going back and forth across the quarry. So pretty nice feature, designed to protect the plane from crashing into this hill, but also aids in keeping our resolution like it should be throughout the whole flight. Hey, the Google Earth just crashed on me, but everybody saw it, so that's a good thing. So I've investigated it, make sure the plane's not going to crash. The only thing that I see here, I know this area has been stripped, but I have a simulator running here. It might say that I have a obstruction if I try to launch it. So I'm going to go ahead and grab my start spot where the plane's going to climb an elevation and move it right here on this haul road. So I can launch the plane. It's going to go and do its thing. There are some things that I can do. Well, it says the camera's off. It's in auto mode now. But if it's on terrain. Yep, it got me. Yeah, did anybody notice that? It's what I have a buddy down in Virginia. He's tried to do this several times in rough terrain, even in simulator mode. The plane was intelligent enough to not really resume the mission because it sees terrain there, and it was too low to it. So anyway, I'll keep moving along here. I'm going to fast forward this. Right here on the main flight information tab, it gives us the wind speed. It shows us it's a crosswind of 1.8 knots. It shows us the ground speed of 20 knots, the air speed of about 23, 26, depends on which way the wind's hitting it, the altitude above sea level or at mean sea level, and the ground sensor height is saying about 400 feet right there, 380, 377. So it shows us the photo footprints here as it's going along. Let it do its thing. And if we keep panning down, it'll show us more information. It says the camera's turned on. There's 46 pictures. Board temperature is 104 degrees, 400ths of a foot RTK precision. All right, almost done. So any questions about eMotion 2? I mean, a lot of folks have already seen this. I didn't want to burn a lot of time on it because I had somebody waiting to do a little presentation to us. It's going to climb. If we're going to be returning to the site a couple of times over, we can save this flight plan to a file and just recall it if needed. Just call it whatever we want. The cave run quarry. Again, the third tab is our flight planning box. If you click difficult terrain and easy terrain, the plane will automatically determine the optimal flight lines. If the plane its ending waypoint is pretty far away from the home waypoint and you want it to be closer when it's done, the shortest distance to get home after it's done, you can reverse the flight direction and it'll fly back from the closest way. You just click it twice and find the closest waypoint for it to fly back from. Anything else intelligent to share here? If you have a Google Earth KML that somebody's given you, it has to be a KML, not a KMZ. You can load the mission area from the KMZ, but you can also save this mission area. So if we just wanted to use it and not necessarily the flight lines because the wind direction maybe changed, you can just save the polygon that I drew around it, or if you pulled it from AutoCAD, you could save it and then and recall it rather than the actual flight lines. I didn't know that till last week, and I've used this thing 1,000 times. This is our waypoints tab, so if we had to bring the plane back and land it for some reason, we can disable waypoints 1 through 20 and just have it finish 21 through 24, just fine checking them. All you have to do is uncheck them, and it won't go to them anymore. If we were trying to do an oblique flight and we wanted to capture oblique images, we just right-click on the screen and then add a photo target. So you start to see that my all right, I didn't catch it.
30, 20.
So that's the gist of doing some flights here. Well, went a little far. That's interesting. It went a little farther than I expected. Usually the landing precision with the RTK unit's pretty much spot on, but it looked like it went about another 100 feet. Must have been slope or something. I don't know. But I'll keep trucking along here pretty quick. Again, if I wanted to save this flight plan, I could go back there and save it, and I think I did. And we can add photo targets in here if we want to do some obliques. You can turn the camera on and off, so if you want to test it before you go fly. You can turn the plane's camera on and off right from the ground. So take pictures. And I think that's about it. So I actually have this data worked up of this query, and I'm just going to show it here for about 3 minutes, and then we'll hand the reins over to Mr. Voorhees. So I'll go ahead and close this out if nobody has any questions about it. And I'll open that project up in Post-Flight Terra 3D. Well, I'm going to try to anyway. It's going to ask you to update your Post-Flight. I'm going to recommend that you don't. I think it's in my Dropbox now. This fellow's name's Jacob, and I couldn't even spell his name right. There we go. Okay, so here's the flight lines that he sent me after he went out and flew it. You can kind of see they look similar to what we did. He just didn't do the perpendicular flight lines to capture his high wall cutaway a little better. And I think that maybe the next time he goes out, he probably will. Our flight parameters that we processed with, pretty straightforward. There wasn't anything special that we did other than I set the terrain smoothing to smooth where it is a quarry and not an area with buildings that I want sharp roof lines. Orthomosaic generation, I had it go ahead and generate a 30 centimeter point cloud, which lends itself to a little smoother contours. So I'll go ahead and pull up the ray cloud editor, and I'm hoping that I took the time. Yes, I did. So this is kind of, I guess what I'm going to show is the difference between what we have built into our software now and what's available for terrain modeling. So I'll go ahead and turn on the densified point cloud. All right, so there's the point cloud, and if you look here, kind of get an idea of what's going on. There's some trucks there. There's a drill that's there. There wasn't a lot of obstruction, but you can see also over here, this area has been disturbed, and he wanted to get contours on it, but we've got, still have some bushes and some vegetation growing on it. And Postlight does have the ability to classify the difference between terrain and objects such as trucks and trees, that kind of thing. So what I'll do is I click this button up here, Process and Compute Point Cloud Classification. So I'll go ahead and turn that on. So what we're looking at is the entire point cloud right now. You can see it. I'm going to zoom in here. We've got some trucks and dozers, whatever, sitting right in the middle of it. And I have the terrain point cloud turned on. So I'm going to go ahead and turn this off. Look what it did to it. And one, it got rid of a lot more data than we needed, but it also left something in there. I can still see the remnants of a bulldozer or something. Yeah, here as well, there's the remnants of something that's not on the ground. So it's still going to contour or build a surface around that. In other areas, it got rid of some bushes and things that stuck up above the ground. I keep moving around, and all in all, looks moderately okay. Didn't do a particularly great job. I'll turn on the objects. Here's the stuff that it deleted or that it moved to the objects layer. It's quite a bit of terrain there that it moved. I mean, you look at it pretty quick and see that it got rid of a lot of data. This is the data that it got rid of. It's just, looking at it, so a whole lot of data. So I can generate a DSM just using the ground terrain there, and it'll take it a while. It's not an instantaneous thing. So if I check it and then say generate it, an external point clouds, I got to run step 3 all over again, which is going to take 20-30 minutes. So kind of what I wanted to show, and these things that I'm saying are leading up to what somebody else's software does a little bit better. There is some options in here for quickly deleting point cloud. This version of Postlight Terra 3D, by the way, for Mr. Moose up in Connecticut is 3.2.98. 3.2.98. Now there is 3.3 point something available now, but it is full of bugs. So if I want to select points to get rid of, I hit my shift key and hold it down, and I can hit the delete key, and it still didn't get rid of it all. If I hit the delete key again, it still didn't get rid of it all. You can still see there's stuff left behind. If I hit the delete key there, yeah, I selected a lot less data that time, and it got rid of that pickup truck. I got rid of the drill, which I still don't think I got rid of all of it. Here we go. And it is a rectangular area that we have to use to select with. So I'll try to make this a bit more square with my screen. Get rid of that drill. Here's a pickup truck. And, oh, there's a drill. I'll try to rotate that and make it more square. So I got rid of the trucks and the, drills and stuff, but, and this was a pretty easy site. There's not a lot going on out there. So this is what we have to work with typically. Normally I would take this in a global mapper and put a surface on it and put some contours on it and then suck it into AutoCAD and dress up my contours, fix it, patch everything up a little nicer and make it look better. But I would say there's another piece of software that is available that is a lot quicker means of cleaning this stuff up and rendering a final DSM and contour set without having to do a lot of recreation inside of post-flight. So I'm going to go ahead and hand it over to Mr. Voorhees. Britton, are you there?
Yeah, I'm here.
Okay. I'm going to, if I can figure out how to get my ducks in a row here. All right. I am old. I don't work things as good as I used to here. Change presenter. Britton works for Virtual Geomatics. They're down in Texas, and he is kind of a support sales. What do you do, Britton? Like everything?
Yeah, you kind of just said it, support sales and everything else.
And everything else. So I'll hand it over to you, and if anybody has any questions, by all means, just speak up.
Hey, so my name is Britton Voorhees. My title actually here is Product Support Engineer. Just some quick background on us. We're actually a LiDAR software company, and we've been working with LiDAR data for about 8 years now. So kind of the UAV thing was kind of new for the company. On my end, I actually did a lot of graduate research work with UAVs. I actually taught a couple field schools out in Hawaii that were using them to collect data for environmental monitoring and things like that. I'm opening the wrong one. No, I wasn't. So what we have here is we had a base engine that actually was really good at already taking in very large amounts of data and pulling out deliverables from them. So you can imagine when you're working with LiDAR data, we're having something like maybe 20 gig files to terabytes of data. And we have unique processing capabilities to actually consume that data and then serve it out to people, and then at the same time pull out extraction deliverables. So a lot of our primary clients in our LiDAR realm is actually DOTs, people working on roadways, a lot of things like that, some aerial guys, a lot of different things like that. And so I was actually approached by a dealer down here in Texas. He told me that, yeah, Pix4D was spitting out a point cloud. That was interesting to me because, like I said, I was familiar that they would do that as I had been using Agisoft during my, when I was teaching, but I didn't know that Pix4D was doing it, and I also wasn't fully acquainted with the EB at that time. So we actually started working on a subset of our software that actually can take in that point cloud, and it's primarily focused at pulling out bare earth, but doing classifications are pretty quick and painless. And there's a couple of subset things you can do as well. And so what I'm actually going to show you is called VG40 UAV Explorer. Like I said, it's kind of a subset of our main software, which has more enhanced capability, but this one is more set to UAV users. So all the data I'm going to be showing you today are actually EB data sets. I don't have an EB, so these have all been provided to me primarily by dealers or customers. So I'm actually going to just open up the set right now. One thing about our software is we try to keep it, this one at least, we're trying to keep it as simple as possible. We don't want you to, our other one has a lot of menus, you have to go through a lot of things to get to places. We're trying to keep that, not go into that realm here, because obviously that's, you guys don't want to be dealing with that. You just want to get in there, pull out your surface, and then pull it into your next platform, which is CAD or ArcGIS or whatever you're going to use. So I'm actually going to bring up, I'm going to bring up this data set right here. So this is, I think this one's like gridded at 1, it's the non-densified, but this is actually the original data set that I was provided to kind of form this product around. So the first thing is this product, you can load up pretty large point clouds. I haven't really seen any of these point clouds from these EBs be larger than, a gig or 2, but you can do up to 3 gigs and possibly up to 4, and it's going to pull in very quickly and easily. That's all, like I said, based on the back end of this software is actually made for LiDAR point cloud. At the same time, and just real quickly is, it doesn't take a heavy computer to do this. Everything you're going to be seeing today is off my laptop, which is my primary workstation, and it is actually, not you, I just like when it does that, but it is, like a normal Dell laptop that I bought for $700, 8 gigs, i7, No graphics card, doesn't need that. So this is something that you can actually probably take this type of software out into the field if you were so inclined and run it there, because it doesn't. The minimum requirements are just a couple core processor with 4 gigs of RAM. But I pulled in this point cloud, and obviously you can do any of the normal things you can do. You can rotate it, you can zoom into it, you can see, you can just manage it in however you want. There's a couple different viewing capabilities. So obviously I'm looking at it right now by elevation, color by elevation, but you can also do classification, which I'm going to unclassify this in a second. For EVs, it would actually be like RGB. So in the same way you were just seeing in the, I think it was the post-flight or the Pix 3D, you can see, when you have this at a full scale, it almost looks like a photo itself. There are other types of visualizations you can do. You could do, if you had something like returns or file ID, things like that, you could actually do that. Not as relevant for EV users a lot of the time, because obviously an aerial platform that's only using imagery is not going to have intensity or returns or things like that. But there might be times where you have LiDAR data and you want to be able to do something with it real quick. You could use this product for that as well. But at the same time, it has there's a couple different ones in here. If I had like pseudo contour bands, we have a lot of aerial guys where just being able to contour it, like color it, helps them visualize it. I don't find it super helpful, but there are people. And then also analysis-wise, if you had change detection of some sort, like it seems like a lot of you guys are taking these things out into the field every week or every month or so. You can actually, I don't have 2 different data sets for the same area that cover the same area at a different time, but you could look at something like elevation difference and X, Y, and Z difference. And those would actually give you, point clouds that you can export out and actually, see where there's actually shifts. So typically, like in my LiDAR world, we're using this for deformation analysis, like on roadways or tunnels or things like that. But for this one, it could be for construction, even vegetation, other things like that. You would be able to set that. And I mean, you can set like the ranges of what you actually want to do with that here. But what I'm actually going to do, that's just kind of starting like the visualization pieces of it. At the same time, there's a couple of just like very quick tools that help you do things. If I zoom into this guy a bit. So this was an interesting kind of area because it had a lot of these bushy patches of trees that really made it kind of difficult sometimes to see where things were, and just for the algorithm itself. So what I'm going to do right here is just triangulate a surface before anything is classified to kind of show you what we're looking at. So not only did it have that, but it had kind of this water hole and a bunch of other different things. And so you saw right there, kind of in the same way that the software you just saw, creating a surface at least that you're able to visualize and look at. It's just a quick key button. But this one also has things like cars right here. You can see all these bushes. And if I zoom out to the full extent, you can see there's some buildings down here, roadways and all that, and then there's a fence line here. So pretty intricate kind of range of things in this data set. You have at least this plain area right here, a lot of closed canopies. It slopes. If we turn on the classification, it slopes downwards. And then obviously things like this make it kind of a bit of a challenge sometimes. So the other parts to it, just to show you quickly, are you can do measurements very quickly and things like that. So if I came here and I had this roadway, I just wanted to measure it, it's as simple as a click and a click. You can see that line right there. It actually gives you those measurements values right there. So it's going to give you something like the 3D distance, the 2D distance, the delta changes, and the slope. Another part of it is any point on this image, I can actually click on it and get information for it. So if I actually zoom back out to the full extent, and let me know if I move a little too fast for your guys' connection, but just want to make sure I kind of hit on everything. But say I wanted just to know the coordinates of this building. When I click on any of these points, you see they kind of highlight white. At that point down here in this data ribbon, it actually gives me information about them. It gives me the X, Y, and Z location. It gives me what class they're in. It also gives me their RGB values. And if they had other things such as intensity or angle or things like that, you would be able to do that. It also tells me what file it's actually in. So you can actually load up multiple of these point cloud files at a time over here. So if you had an area or you had a bunch of ones for an area that were split into pieces, you can load those all up at the same time, view them. It's not going to be a problem for it. Like I said, it's used to handling pretty large data sets. Just kind of another end of that is if you had 3D shape files or break lines or something included, in shapefile format, you would be able to load those into this as well and view them in 3D. So if I had, if somehow I digitized out the edge of this top building, I could actually see it in the profile, and there'd be a floating line around there. So if I actually kind of move through, in the tool-wise, those are a lot of the ones that are like this straightforward and going to help you to do things. One cool one too is it actually has a pretty unique, or not unique, but pretty good profile tool. As this used to be kind of an aerial LiDAR software, it has a lot of tools to help you do things like that. So I can actually click across right there, and it's going to give me a profile, but I didn't give it any depth right there. So I can actually go back into that and give it some depth, and we'll actually see something. So you can see there's kind of a box there. So I created a profile for it, so I can see a profile of this boxed area up here. And down here in this viewer, this is the exact profile of all those points. I can actually look at change the way the point cloud visualized. So I can click on it by classification, which, when you're doing some, that's going to be really helpful, or by file ID. So if you had multiple files, it'll show you which ones are which. Intensity as well. And then I could do measurements in this as well, which is something that could be helpful. If I wanted to measure the height of this building, it's as simple as drag and drop there. Down here, it gives me the XY difference, and it gives me the Z difference. So you're very quick to get kind of those things. A lot of couple different other ones, such as I can increase the Z exaggeration. There might be instances where you have very minute features close to the ground. You want to be able to pull them out and see them. And, just a couple other tools that really are kind of project specific, but they're there, and we'll come back to that profile guy a little bit later when we get more into the classification. But just real quickly, that's how you can like get into your data and start looking at it and just analyzing it. That's all you want to do. Another tool that actually we have within this is the ability to, on the fly, kind of change the data you're working with. So So I can actually go to here on this on the fly guy. And intensity and GPS time aren't going to be a big deal here with this one, but something like Z exaggeration, or the Z, I can actually threshold out values from that Z and get rid of them. So it's not as critical within this UAV realm, but you still have that ability. But the way it works is, if I don't want to see anything, if right now I'm seeing ranges of elevation from 1493 to 1564, I can actually start thresholding the back end. You see things start disappearing. So in this environment with the elevation changes, it's not as useful. But if you have a flat one and you have tree cover, things like that, it'd be very easy to, set in whatever steps you want if I wanted to do in steps of one, and kind of just threshold them out real quickly, just if I was so inclined to do that. It has that ability. But the main thing that it's actually, see, it looks kind of funny right now. The main thing that it's actually built for is to pull out that bare earth quickly and then get it into your next process. So to do that, it's actually we've created it into a 2 or 3, maybe 4-step process. Obviously you load up the data. That's going to be the first step. That's straightforward. You saw I would just go to file load. At that point, I would actually start running the automatic filters for it. So right now, this one I use this one quite frequently for testing. So I'm actually going to shove everything back into unclassified. That would be around what you guys probably receive it from the Pix4D. And at that point, we have that same point cloud except everything is unclassified. You can see it's all gray. If I click on any of the points down here, it tells me unclassified. And if I tried to tin it, everything, you know, if I create a surface out of it, it's going to include all the trees. It's going to include everything because it doesn't know the difference between any of them at this point. So going back to our LiDAR background, we had a lot of different algorithms that kind of do things similar to this. So we modified one that was used with our aerial platforms, our aerial software, to this EB one. And so it looks basically similar to that guy. And if I actually pull it up right here, it's called the ground filter, the airborne ground filter. You can see it's a pretty straightforward menu. We tried, like, this is where I was saying we were trying to keep it very user-friendly, and you guys don't have to actually put in the parameters or things like that. What the main thing you would need to do in this is set your aggressivity, and that's kind of just a black box value. You know, if you run it and it doesn't pull out enough points, you maybe want to increase the aggressivity or decrease it depending on what's happening. Most of the time, I usually keep it on 3. I'll start off with that, and things go by pretty well. The units, obviously, and then it's going to ask you for the input class. So in this case, you know, it's something like unclassified. If you had a classified set, you just have to say which ones it was. At that point, you're basically set to go. It's going to ask, it's going to say, where do I want to move my ground points to? Where do I want to put my low vegetation point, or my non-ground points? And then it does something else, which is, this one's a work in progress, but it moves points it identifies as building to a building class. So on this one, it has a bit of a problem because of the vegetation canopy, but you'll kind of see what the theoretical hope is for that eventually. And then, you know, if you're getting poor results, you are able to change the terrain type, even get as specific as you want right here with the manual, and put building size and delta changes in the Z. I most of the time just keep it on compute because it figures that out pretty easily. At that point, I just press OK, and it's actually going to run on this data set. So it's going to take a second, and depending on it's pretty quick. It just really depends on the size of your data set. But at that point, you know, it's really a hands-off approach. This guy's going to run. Then you kind of just wait around for the results. While it's doing it, I want to bring up a secondary. So it finished faster than I could bring that up. But something else it does is it actually, this one might be interesting to you guys, is you can actually, I'm clicking way faster than I want to, but this is a different data set, and it may be something you guys are more familiar with because it's an actual mine, so I'm going to zoom into that area. But one tool that I hadn't shown you yet was that you can actually do volumetric calculations very easily with this as well. So if you look at this data set, obviously we have a road right here, and you know we have some stockpiles or mine just pile-ups or whatever we want to call them. But if we had some kind of stockpile monitoring that we're doing, or you want to get your volumetrics every week, it'd be a pretty easy process. So if I actually go to this guy, we can say, I just want to measure the volume of this guy. We see there's kind of this isn't a classified point cloud, but there's the elevator coming off this. But just for fun, I want to show you how the volumetric works. So it's actually right here. It's another tool. When you do this, because you can use this for a QA QC as well if you wanted to digitize polygons. But when you do this, you just say yes, I want to enter volumetric, and this is going to be as simple as clicking my perimeter or however I want to do it. And obviously, this is kind of rough, but you just click around it. It's going to ask you for the units once you finish that. Press OK. And it actually pulls up that volumetric information. So it gives you the cut, fill, volume, the area of that polygon you just made, all those different things in this box. So right now it's just kind of here. You press OK, and then you just say what you're going to name that. Press OK again. Okay. At that point, it did a couple different things, which you just saw. First, visually, it showed you where the cut and fill is. So because it calculated the ground here by itself. So anything that's in red is where it was going to cut. Anything in green is where it was going to fill. So you visually get that first. Second, I can actually go here and go to export volumetric information, and it'll actually save first that window you had with the volume information, but it'll also save a snippet of the LAS for that polygon, and it will also save a polygon shapefile that has that fully attributed of that volumetric information. So you can take those out very quickly and go to whatever analysis software you use, even if you're just using this as a kind of a inventory that you put into an Excel sheet or something. You have that ASCII file, you have the shapefile, you have the LAS snippet. You know, either way you want to do it, you can pull those out real quickly and take that to another guy. In that same way, just the last piece on this volumetric, in that same way that I was talking earlier, you can pull in multiple shape or point clouds. If you had, you know, temporally, like I had one for a month ago before this one, and the stockpile didn't exist, I can actually use that one as, I can designate that as the base, you know, because I can load them both in at the same time, and it'll ask you which one you want to use as a base, and so that way you can actually get measurements that were based off of one from the month before or the month ahead, et cetera, et cetera. But, you know, the output for it would be the same. Going back to this guy, like I said, the main thing you want to do is get your classification. So you can see right away, if you remember the environment on this, you know, we have this vegetation canopy right here. It's pretty dense. It's basically closed. It has a couple little breaks. A lot of croppings of trees. And then, you know, we have a fence line right here, roads, some cars, and buildings right here. If I go to the classification, it classifies it into those three classes, which would be ground, vegetation, which is just going to be which signifies non-ground, and then buildings. So it actually goes through and tries to identify buildings, and it does the best on buildings that are rectangular in shape, that don't have like the A-frame, but are kind of like prototypical building types. You know, if you have some really strange building types, it's not going to find it as well. But what it's looking for is kind of a flat surface that a building usually has. But so what you see right away here is it pulled out a lot of the vegetation pretty quickly. You can see it on here, you know, where the vegetation is. You can even see something like right here, this fence line. It even identified that fence, a lot of the grass points that were here, most of this, and then the other one, like in red, you can see the building. So that's one of the things, like I said, that's a work in progress. But if you remember down here in this bottom right corner, we had this large warehouse building, and then this one. It actually did a not so bad job of identifying those and pulling them out. The one problem it did have is it also thought a lot of this canopy right here, which has a lot of similarities to that building, was the building class as well. But that's not the hugest problem for this set of data, because the focus isn't on finding buildings. You know, that was just kind of a gimme we throw into the tool. It's actually on filtering out the ground. And so what I can actually do is look at things by classes. So if I wanted to see the ground only, I can turn that on. And I'm going to turn this on its side a bit, and just to show you, because that first filter, especially with this data set, does a decent job. But just like maybe the one that Chris was showing, doesn't get everything. And it's going to look bad, but it's an easy fix. So if I actually look at the surface, okay, definitely had problems, you know, with these vegetation canopies that had that were more sprawling, you know. Ones like right here where it was just kind of a patch of trees, or here, it found those pretty easily. There would be a couple ways of fixing this, and this is where I think our tool starts to shine a lot, is we make it very easy to manually fix your data if you need to, and I'm going to show you how to do that, and then I'm actually going to show you the last filter that I could have used to bypass a lot of the manual stuff that I'm about to do. But say this is what I got, and I'm going to have to go through and fix this. You know, I can very quickly do a couple things. First, I want to go to this area because it's full of problems. And I'm going to tint it just so I can see it. So like I said, there's all kinds of things going on here. and obviously that's not any kind of ground you want to do. So I can actually turn on this magic wand tool, and it gives me the equivalent of basically a paintbrush. So I can take this paintbrush, move it over this canvas or this surface, and anything below it, it's going to put into a different class. What I'm going to do right now is put everything into created, so it's going to make it pink. We won't see it for a second, but the way it works is it says where do you want to put it, what's your brush size, and what type of trimmer. I'll say all, so anything underneath my cursor is going to go into this class. And I can actually hold my left mouse button, and as I'm dragging across, everything that's underneath that cursor will be pulled into that class. So one thing you see is the surface or the tint of it as I'm going across. It colors itself, showing me which triangles which are associated with the points are going to be pulled into the new class. And when I actually let go of this, it's going to automatically calculate this by itself and recalculate the surface. So I'm kind of fitting things broadly, but like right here, you can see like if I have some brown and white intermixed, I obviously didn't get all the points I thought I was going to get right there. If I let it go, it recalculated that surface, and if I rotate it, it's still got problems along the edges, but I could go here and start getting those out very quickly. So the ideal is, and this is like I said, a little bit more of a challenging data set, is you're going to be doing this only on very minimal instances. You're not going to have to be sitting here doing this like this. But that's how quick it would be. The other way you can actually do on classification is if I shift my frame out a bit and turn on all the classes again, so we can kind of see everything that I have rather than just the ones that I pulled out. Let me pull this off. Is I can actually do a classification like that through my profile tool as well, which I had shown before. So if I turn this profile tool on and again and make a profile of that same building, and you can see here's the building itself, and if I click on this right here, you get a line through the profile. It's a little hard, we're a little limited on screen space here. But this is the building, and as I click in the profile view, you see that line up here will show where I'm clicking in this. So you can pretty easily correlate the two between what they are, but I can actually do a classification in this, and this is where things could get real fast, real easy if you wanted to. I have that same tool brush if I wanted, so if I click on this paintbrush, I'm going to actually put things into a different class because I forgot that the created still tins, but if I do this, if I put them into low point noise, you can see as I'm moving across, all these points are going into low point noise, which is orange, and this one. I could as easily do it like that. So there's a fine-tuning way of doing that, or, which is a lot easier, is if I have something like that big vegetation canopy or a building or something that's having a lot of problems, I can actually go into this line-based mode. What this allows you to do is actually draw a line and say anything above or below this will be in a certain class. So I can actually follow the surface pretty quickly on my own and double-click. And what I'm going to say is anything above that line is going to be in the building class because it's red and it shows up pretty well. I tell it that, you see everything popped up as red. And then just to finish it off, I'll say everything below it is in ground, below line ground. I probably got a couple points I didn't want to, but that's fine. And I'll close that up. And then I will close this, and we'll see it recalculate up here. And you see right there, pretty quickly, everything, like I said, that was kind of in that rectangular profile. It's all either at this point in the ground or the building class. So classification-wise, you can see how quick I can manually do it if I was so inclined to do that. I am lazy. I don't like to sit there and do things like that all day. And so we actually added on an additional filter for instances like that, like this, where you might have something that's a little more challenging. Because you can see we have a lot of mess through this still. So the last filter on here is actually a vegetation filter, and it's going to look at the differences in by every point, and then throw things into a different class. So if I actually open it up, This one's not as black box and easy because it takes some parameters. Basically, like I said, it's kind of looking at a nearest neighbor and saying, okay, are you close to the ground? Are you close to me? If you are, let me look at the next guy and look at how close he is. It goes kind of through this iterative chain of that. So I can actually go to this guy and say, hey, anything that has units, which are going to be in the units of your data, so this would be feet. If you had it in meters, it would just be talking in meters. But anything in these units, you know, and I'm going to throw created in there too, throw that into the water class. So I'm just going to run it. And so if you imagine, instead of doing that manual portion that I just demoed to you, I was showing that to you just so you see how the manual works. If I ran that, if I open this file up, I ran this first ground filter, right, and then I ran this secondary one. This is what you would get from 2 filters that took you about 5 minutes to set up and run, is this one right here. It's not perfect yet, but if I triangulate it to just look at the surface, I have a pretty close to probably what I need, depending on how accurate and your different specifications on this. You know, there's a couple points right here where, you know, obviously we're going to go in and clean those up, and that's where, you know, going into this guy, grabbing, I'm going to put them in building now, grabbing this and, you know, just hitting that point, you know, that one's gone. And this is where I was saying earlier, you're going to, hopefully you're not going to be doing like that intensive kind of stuff that I was just doing a second, where I'm doing points all over the place. That is as quick and simple as it should be, you know, hopefully. Obviously every job site's different and there's going to be challenges to every one, but you should be able to run this in that type of environment. Once you have it like that, once you have a product like this, you know, and you're happy with this, you can actually now do a couple things with it. I can export it in a couple different ways. So primarily what we found, and this might be changing, we're not sure yet, are most of our guys want it, and they just want that surface in an LAS format. So it's not going to grid it or anything like that. And if you want it to move on to tools that are actually going to grid it and create DSMs or DTMs out of it, or you want it to be able to create 3D shape file, 3D line work and things like that, you know, that would be where you go to the next step and move up to our other product. But in this one, you know, you get that ground, and I can actually export that, you know, into an LAS file. So if I only have the ground selected, such as now, it's going to export only the ground points into its own file. I can also take that into an ASCII file, or I can export the contours as a shapefile. Shapefile triangle is kind of weird, but some people do use it that way. But it's going to just spit those out right away, and at that point, you know, you can take that into your next system and move on with the project. There are going to be some other kind of just very little tools, but in the overall broad sense, that's kind of where this tool sits, and what it's meant to do is really just help you to move things very quickly. I guess at this point, if you guys had any questions, I could answer them.
Yeah, what about contours, Britton?
So it does contours at this point, in the same way that...
Okay, there we go, cool.
So there's a caveat to these right now. It does contours, and what I've found is, because the problem is a lot of guys, or what I've actually found is most of my guys, you know, will take something like this and put it into ArcMap or something else, and then run their contours in that, because they can set a minor and a major interval and do different things like that. So this one, the contours are really meant for visualization more than export. You can export them. I think they're a little tweaky, and you're probably better off just spitting this into a different product, but it is available. In that same way, just to show you these contours, what I mean by visualization sense is, yeah, I can turn them on, I can start doing things, but they're really meant for, because instead of I use the 10 a lot, didn't mean to do that, but to do like this manual classification. But if I actually wanted to, I could use the contours in the same type of way. So if I start hitting here along this 10, sorry, it'll actually recalculate those contours as well, just on the fly. Okay. Are there any other questions?
No. It's like the slim and trim version of what I have.
Yeah, and that's kind of what we found. You know, like I said, we were approached by a dealer down here, and you know, he's just like, we need something that's easier, and that's kind of where we're trying to sit with it.
Well, that's I don't know if you remember me calling you and is it Dan Parker? I don't know, a couple of gentlemen from Virtual Geomatics, and I was saying, what's the light module? What's the main one? And we had, and then you must have talked to somebody that was making more sense because I was trying to do the same thing. Back to this
I think you probably talked to John Clark or something like that.
Maybe.
You know, yeah. It was just before I was kind of involved with getting on, trying to get something going.
So excellent, man. It's some really neat stuff. It's just a better way of, I mean, it manipulates surfaces much quicker than we can do it in anything else. That's why I wanted you on here today. So does anybody have any questions for Britton?
What kind of cost breakdown do you have on the program?
So I think you can probably talk to Chris about cost more so, but the way we're orienting it, I think usually it comes out to $2,600 for one seat, and so you'll get and that'll be full cost. So the list price for the software is like $2,000, but then there's taxes and other kind of little things that always add up. But you get the one seat of the software and a licensed dongle, and so that dongle is like a USB key. It's fully networkable, so if you have it plugged into a computer, that computer obviously has a license, but if that computer is plugged into a network, any computer on that network could actually key into that license as long as you're on the network, even if you VPN'd into it or something like that. So it gives you flexibility in the sense that you can take that key out you can take it out into the field if you didn't have some kind of connectivity, or you can plug it into a license server and it's just going to act on your network, and whoever's on the network can access it.
And that works with any kind of point cloud database that we have. If you pull a point cloud in from a terrestrial-based laser scanner, or you use LiDAR, you use something from the UAV, it doesn't matter as long as there's a set format they will import in, and you can use any point cloud.
Any LAS style format point cloud you have, so it's going to be looking for LAS only. You don't have any kind of conversion tools to convert between formats with this kind of subset software. But if it's an LAS format, and it doesn't matter if it's LAS 1.1, 1.2, or 1.3, it'll pull those in. You could even, if I had this area and I had a terrestrial scan down here on these buildings, I could load both of those in at the same time, potentially, depending on sizes, obviously.
And
yeah, that's
what
really
is
cool.
The deliverable that this software, it is still a point cloud when it comes out, still an LAS file?
You can have it as that, or you can actually export it as an ASCII file. So it'll be a text file that has the XYZ RGB values and classification.
Or triangles.
Yeah, triangles come out as shapefile format, so it's a little funky. Like I said, from my experience, and maybe you guys have a different opinion on this, like most of my guys, they take this and then they fold into their CAD and they actually create their triangles there, or they pull into ArcMap and do it there. They're more familiar doing it there, and they have little intricate processes they want to kind of keep on the workflow on that end.
Well, gentlemen, this is awesome. Thank Britton. I certainly thank you for teaming up with us today and coming in and showing some stuff that I'm not very, fluid in showing. If anybody has any questions for Britton, I guess they could, drop us or questions about virtual geomatics. You could drop us an email, whatever we need to do. And if you have any questions about the EV product, you all should have my email address somewhere in your register. But what this ultimately does is a quicker, faster way of cleaning noise out of, and I refer to noise as trees and everything else, out of your your point cloud data that you have coming out of our Sensefly Pix4D product. So I thought it might be nice to have them on here. This manipulates huge data sets at one time. If you got huge areas that you're doing at one time, this is a pretty quick and dirty way of a simple way of doing it. This is what I used originally, and then you know, I've had to learn 5 or 6 other pieces of software for other reasons. So it's finally nice to get this stuff on a forum and be able to show
it. Is there any way that we can get a copy of this presentation? Are you going to link that?
Yeah, I'm recording it right now, and when we're done, I'm going to put it on Dropbox. So if you want a copy of it, just reply back to my email, chris@karaneast.com. And I'm trying to figure out how to get it on our webpage at ebusa.com. And I don't think the IT guy understands Hillbilly so well. He just doesn't understand what I'm saying to him. I'd like to put this video on our webpage. And we're working on that still. So they should be coming up available here before too much longer as well, right off our webpage. But I'll put it on Dropbox, and if you'd like a copy of it, just drop me an email. I'll make sure it comes. You get a link to download it.
Great, thank you.
But anyway, guys, I appreciate it. Britton, do you have anything else to? Oh, there's Britton's information if anybody needs it. If anybody else has any other questions, you have our email addresses, and I guess have a wonderful Friday.